Hello, Math 2 students. Today we're going to change from knowing that figures are similar and finding their missing sides, missing perimeters, and missing areas to having two figures and proving that those figures are similar by looking at their angles. First of all, for two polygons to be similar, they must meet two conditions. The first condition is all of the corresponding angles must be congruent. So we have a picture of two quadrilaterals, and if we compare their corresponding angles, we can see from the picture that all four pairs of corresponding angles are congruent. So this pair of quadrilaterals meets the first condition. The second condition is that all of the corresponding side ratios must be equivalent. So if we look at the side names, we can form four ratios or four fractions that look like the ones here. If I replace the names with the measure of each side, the fractions would look like this. And if we reduce those, they all reduce to 3/2. So the scale factor of these two similar quadrilaterals is 3/2. They are considered similar because they meet both of the conditions mentioned here. Are these triangles similar? Well, in order to have similar triangles, there needs to be two requirements so far. One requirement is the corresponding angles must be congruent. 60-60, 70-70, 50-50, the corresponding angles are congruent. And the corresponding sides need to be in proportion. So 13 times 2 is 26, 8 times 2 is 16, and 12 times 2 is 24. So it seems like the scale factor might be 2, or some people might say that it's 1/2, but the sides are definitely in proportion. Can we say that the triangles are similar if we only know about the angles? What if we only know about two angles? And the answer to that question is there is a special rule. So similarity happens if all of the angles are congruent and all of the sides are in proportion. But there is a special rule that says if two angles of one triangle are congruent to two angles of another triangle, then those triangles are similar. And that is called the angle-angle similarity theorem. So first we're going to review a couple of things that are important about triangles. The three interior angles of a triangle must always have a sum of 180 degrees. We're going to use that quite a bit. If we have a pair of triangles and they form a bow tie, we will always have one pair of congruent angles. Those are the vertical angles in the picture. And finally, we need to review some things about parallel lines and how that's going to relate to triangles. So if we have a pair of parallel lines intersected by a third line, that third line is called a transversal, and it forms four pairs of angles that are congruent. The first pair that we're going to look at is below the parallel lines and to the left of the transversal. Those are called corresponding angles, and they are always congruent. The second pair is above the pair of parallel lines and to the left of the transversal. Those are corresponding angles, and they are congruent. The third pair of angles that we're going to look at are below the parallel lines and to the right of the transversal. Those are corresponding angles, and they are congruent. And the final pair are above the parallel lines and to the right of the transversal, and those are congruent corresponding angles. If we add a second transversal, the same pairs of angles are formed. We have a pair that's below and to the left, and those are congruent. We have a pair that's above and to the left, and those are congruent. We have a pair that's below and to the right, and those are congruent. And we have a pair that is above and to the right, and those are congruent. So how does that relate to triangles? Well, in our picture, we have at least one triangle that looks like this, and we could draw a second triangle that looks like that. And so we'll be learning about whether or not the yellow triangle and the pink triangle are similar triangles. That angle is above and to the right. That angle is above and to the right. And so those are congruent angles. This angle is above and to the left. And this angle is above and to the left. So those are congruent angles. So when we take these overlapping triangles and draw them so that they're not overlapping, the yellow triangle would look like this and the pink triangle would look like this. Finally, when it comes to this picture, we know that these three angles have to add up to 180 degrees, and so do these three. And so if we take 180 and subtract this angle and this angle, we'll get the same answer as if we take 180 and subtract this angle and this angle. So whenever you have a picture of triangles that looks like this, you will always have a pair of triangles where all three pairs of corresponding angles are congruent.
All right, make sure to do these 3 examples with me on the video.
So on number 20, we have triangles that look like this. The difference is now we have side lengths. So when I draw the triangle so they are not overlapping, the yellow triangle has sides 4 and 6, and the pink triangle has sides 5 and x. But I've already made a mistake. The pink triangle doesn't actually have a side that's 5. If you look at the pink triangle, the side is actually 4 plus 5, or 9. So the first part of problem number 20 is to choose the answer that says the side of the larger triangle has a length of 9, not 5. The second part of the problem is they want us to find the length of side x. So I'm going to write a proportion. 4 over 9, which are corresponding sides, equals 6 over x, which are corresponding sides. And I find the cross product and get 4x equals 54. And when I divide by 4, I find out that x equals 9. So on number 20, the last part of the answer is that x equals 9. On problem number 24, they're talking about how all right triangles are similar. So before I even do any other part of the problem, there are 2 right triangles and they definitely are not similar. So I can eliminate that answer choice. Now, when I look closer, it tells me that triangle JKL is a right triangle. And it tells me that angle X plus angle Y should add up to 150 degrees. Now, what they really want to know, is it possible for these triangles to be similar? Well, if they're going to be similar, then if angle L is a 90-degree angle, angle Z also has to be a 90-degree angle. If I subtract, I can find now that angle X has to be 60 degrees. And if these are going to be similar triangles, then angle J also has to be 60 degrees. So right now I've just answered the question. Is it possible for these triangles to be similar? The answer is yes, because it is a special case, which in math is called the AA similarity. If you're dealing with triangles and 2 angles from one triangle are congruent to 2 angles of another triangle, then those triangles will always be similar. And with a little more subtracting, we can see that actually all 3 angles are the same. So these are definitely similar triangles. And finally, on number 25, they want us to draw 2 triangles again. They don't really tell us what they look like, but I drew 2 triangles that look like this. Angle L is 87, angle Y is 94. And if these are going to be possibly similar triangles, then angle Z has to be 87 because they are corresponding angles. And angle K has to be 87 because those are corresponding angles. And so if I look at it initially, I would think that this is the special case. This is AA similarity. 2 angles of the pink triangle equals 2 angles of the yellow triangle. The problem is that if I subtract 87 and 94 from 180, I get -1. And so the correct answer choice on this problem is the third choice. 94 plus 87 is greater than 180. So although these angles pairs are the same, you can't even make a triangle with a 94 and 87 degree angle in the same triangle because they add up to more than 180 degrees.
All right, Math 2 students, if you're working on assignment number 33, that's from section 8.4, part 1. This picture is the picture for problems 12 through 18. And the first thing you need to know about this picture is you need to know the measure of every angle and you need to know the length of every side. So here we go. Write this down on the diagram. First of all, this angle is 45 because in this triangle, we have 180 degrees minus 45 minus 90, and that leaves 45 for that angle. This angle is 45 because the 45 here and the 45 there are vertical angles, and vertical angles are always congruent. This angle here is 45 because the 45 and the 90, if we subtract those from 180, we find out that this third angle of the triangle will be 45. This is a 90-degree angle, so the one adjacent to it is also 90 degrees. This angle is 37 because when we take 180 minus 53 minus 90, we're left with 37. This angle is 37 because these are vertical angles, so they are congruent. This angle is 90 because it's adjacent to the 90-degree angle there. Now if we take 180 minus 37 minus 90, we'll have 53 for this angle right here. And that's all of the angles. Now for the sides. If it's 7 from A all the way to B, and it's 3 from A to G, if we subtract, we can find out that this distance, GB, is 4. All right, in this triangle, if we look at the sides that we know, this is 3, this is 4, and this is 5 because it's a 3, 4, 5 right triangle. This side is 4 root 2. How did I know that? I put 4 and 4 into the Pythagorean theorem. So I did c squared equals 4 squared plus 4 squared, and I found out that this is 4 root 2. This side is 15. The way that I knew that this side was 15 is because the scale factor between this triangle and this triangle is 3. So the 3 grew into a 9. So the 5 is going to get 3 times bigger, and it's going to grow into a 15. Also, the 4 is going to get 3 times bigger, and it's going to grow into a 12. In this triangle, I know that this one's 12 because GB is 4 in this triangle, and these triangles are similar. So if the scale factor is 3, and this one's 4, that one's got to be 12. All right, now that you have that diagram, you should be able to finish those problems from 12 to 18 with no problem.